In the previous lecture, you explored how retrieval augmented generation systems must be secured to prevent manipulation and data exposure. Now you move deeper into the foundation of artificial intelligence itself, the data and the training pipelines that shape model behavior. If retrieval security protects knowledge at inference time, data security and training pipeline protection safeguard intelligence at its origin. You must understand this clearly. The integrity of your artificial intelligence system is determined long before it generates a single response. It is determined at the moment data enters your training pipeline. In this session, you will examine how to secure data lineage, ensure dataset integrity, validate training data, and protect machine learning pipelines at enterprise scale. Before exploring controls, let us establish the context. Artificial intelligence models do not create knowledge. They learn patterns from data. That data influences their reasoning, biases, decision boundaries, and response patterns. If the data is compromised, incomplete, manipulated, or improperly governed, the resulting model reflects those weaknesses. As a leader or architect, you must shift your thinking from protecting model outputs to protecting model formation. Data is not just input, it is architectural DNA. If you do not protect it, every downstream control becomes reactive. Now that you understand why data is foundational, let us examine data lineage. Data lineage refers to your ability to trace data from its origin through transformation, storage, training, and inference. You must ask, where did this dataset originate? Who collected it? What transformations were applied? Who modified it? Which model versions were trained using it? Without lineage visibility, you cannot assess risk. Imagine an enterprise deploying a customer support model trained on historical ticket data. Months later, regulators question whether personal information was included in training. If lineage records are incomplete, you cannot confidently answer. Data lineage enables transparency, accountability, and auditability. Architecturally, lineage tracking must be embedded into your training pipeline. Every dataset must be versioned. Every transformation must be recorded. Every model must be traceable to its training data sources. Data lineage is not documentation overhead. It is a governance requirement. Now that you can trace data, let us discuss protecting its integrity. Dataset integrity ensures that data used for training has not been tampered with or corrupted. Threats to dataset integrity include malicious insertion of biased records, unauthorized modification of labels, accidental corruption during transformation, inconsistent preprocessing across environments. Consider a fraud detection model. If an attacker subtly modifies labeled examples to misclassify certain transactions, the model may learn incorrect decision boundaries. This is not a traditional breach, it is training data manipulation. To preserve dataset integrity, you must implement access control on raw and processed datasets, cryptographic hashing for dataset verification, separation of duties between data engineers and model trainers, continuous integrity monitoring. Integrity controls protect the foundation upon which intelligence is built. Now that you understand integrity, let us examine validation. Training data validation ensures that data meets quality, compliance, and ethical standards before being used to train models. You must evaluate: does this dataset contain sensitive personal information? Does it contain biased or discriminatory patterns? Does it include unauthorized proprietary content? Does it meet regulatory requirements? Imagine training a human resources screening model on historical hiring data. If that dataset reflects historical bias, the model may perpetuate discriminatory practices. Validation is not only technical, it is ethical and regulatory. Architecturally, validation processes should include automated checks for data quality, anomaly detection, and manual review for high sensitivity use cases. Training data validation protects your organization from reputational and legal risk. Now that you understand the importance of secure data, let us expand to the training pipeline itself. Machine learning pipelines orchestrate data ingestion, pre-processing, training, evaluation, and deployment. These pipelines are complex, automated workflows. If compromised, they can introduce malicious code into training environments, inject unauthorized data, modify model parameters, deploy unverified models. Pipeline security must therefore include strong identity and access management, segregation of development and production environments, code review and version control for training scripts, artifact validation before model deployment, logging and monitoring of pipeline activity. Tools such as MLflow, Azure Machine Learning, Vertex Artificial Intelligence, and Kubeflow provide structured pipeline management, versioning, and governance capabilities. However, you must architect secure patterns around them. For example, model artifacts should be signed before deployment. Training jobs should run in isolated environments. Access to production models should be tightly controlled. The pipeline is not merely a workflow, it is the supply chain of intelligence. Now that you understand the pipeline, let us contextualize enterprise tooling. MLflow enables experiment tracking, model versioning, and artifact management. Azure Machine Learning integrates with enterprise identity systems and provides role-based access control and monitoring. Vertex Artificial Intelligence offers managed training pipelines with integrated governance capabilities. Kubeflow enables scalable orchestration of machine learning workflows across distributed environments. These tools support traceability, version control, and reproducibility. But tools do not guarantee security. Your architecture must define who can trigger training jobs, who can approve model deployment, how datasets are approved for use, how lineage is recorded and audited. Tooling supports governance. Architecture defines governance. Now let us look ahead to a future trend: the artificial intelligence software bill of materials. In traditional software development, a software bill of materials documents components, dependencies, and versions used in an application. In the context of artificial intelligence, this concept extends to models. An artificial intelligence software bill of materials would include training data sources, pre-processing steps, model architecture details, third-party libraries used, fine-tuning datasets, version history, deployment environments. Why does this matter? Because regulators, customers, and boards will increasingly demand transparency. They will ask, what data trained this model? Which components were involved? Has it been updated? Has it been validated? An artificial intelligence software bill of materials provides structured accountability. As an architect, you should begin designing your pipelines with this future expectation in mind. Transparency will become a competitive advantage. Let us consider a practical enterprise scenario. Your organization develops a predictive maintenance model for industrial equipment. The training dataset includes sensor data collected over years. If lineage tracking is incomplete, you may not know whether corrupted sensor feeds influence training. If validation is weak, sensitive operational data may be embedded in the model. If pipeline controls are weak, unauthorized model versions may be deployed. If no artificial intelligence software bill of materials exists, you cannot explain the model's evolution to regulators. By embedding data security, integrity validation, secure pipelines, and documentation from the beginning, you transform risk into governance strength. Now that you understand the architecture, elevate this to leadership thinking. Data security and pipeline governance must be part of enterprise artificial intelligence strategy. You must ensure every model has traceable lineage, every dataset is validated before training, every training pipeline is secured, every deployment is auditable. Artificial intelligence adoption without data governance is unsustainable. As a leader, you must treat data and pipelines as strategic assets, not operational details. Now that you have explored data lineage, dataset integrity, validation, and secure pipelines, let us summarize the essential insights. Data lineage provides traceability and accountability. Dataset integrity protects against manipulation. Training data validation ensures quality, compliance, and fairness. Secure machine learning pipelines prevent supply chain compromise. Enterprise tools support governance, but architecture defines control. The artificial intelligence software bill of materials will become a future expectation for transparency and trust. Securing data and pipelines protects intelligence at its origin. Now that you understand the foundational importance of data and pipeline protection, reflect on your own organization. Do you know the lineage of your deployed models? Are your datasets validated and monitored? Are your training pipelines governed with architectural discipline? If this lecture has strengthened your perspective, subscribe to the channel so you do not miss the next session. Like this video if you believe data security is the backbone of trustworthy artificial intelligence. And share your thoughts in the comments. Is your organization treating model training pipelines as critical infrastructure or as background automation? Let us build secure, transparent, and resilient artificial intelligence systems together.